Hello, everyone. Thank you for joining and welcome to our webinar from Trimos India. This is Vishesh and I'm Venkat. We are calling today from the Pune, from our Pune office, which is also our head office for Trimos India and Trimaster Metrology, which is the group company of which Trimos is part. We're very happy to have you here today. In fact, and we're very happy to present something that we think is quite a trendsetter in the world of metrology. Very new type of equipment that perhaps you may have heard about, perhaps you may have seen, but today we will get to see it up close. So, Vishesh, we're going to just we'll also present it in a format that we hope will be quite interesting and engaging for all of you. So, without much ado, Vishesh, I want to just ask you a few questions about this equipment that we're seeing here. Actually, what can you tell us briefly about this what is
the portable shop close here?
Portable shop close. So, I mean, when I have heard of CMM, normally, I think of, basically a bridge type CMM, right? So how is this different from bridge type?
It's it meets you halfway where you are able to bring the inspection right on next to your machining center, and you don't need to take the parts all the way to your standard room where the CMMs are usually there.
Okay. So yeah, I mean that's pretty interesting because so you are saying that. But how is it? I never heard of the CMM that can travel. I mean, surely can I carry this around?
It's extremely lightweight, 13.5 kilos. You can just carry it like a baby.
Oh wow!
It comes with a trolley that you can just roll it on your shop.
Okay. God, can you just bring the other one? Yeah. So that's pretty. 13.5 kilos is it's almost like you'd say like a 3 or 4 year old baby, isn't it?
Yes,
it's like carrying a small baby. So there you go. This is how easy it is to carry this little baby over here. Very interesting piece of equipment, and but how do you see? So, for example, on a traditional CMM, what have you seen as some of the? Obviously, nobody here is berating the traditional bridge type CMM. It is a fantastic piece of equipment. It is a well-proven technology. It has existed for 30, 40 years. Highly accurate, highly repeatable, very robust piece of equipment and proven across the breadth of manufacturing sector. So definitely, that is not a technology that is going anywhere. But what do you see as the limitations of that? I mean, why this product?
Typically, what we've seen on the bridge CMMs is it's more application focused and more accuracy focused. So when you have some certain parts that you cannot do, then you just have to head there. But for this technology is going to bridge you a gap between having the more basic and fundamental inspections being done on the shop floor in 3D at the point of machining itself.
So you said you can do 3D inspections in the shop, right? But aren't there already certain, like on the shop floor, I understand there are already some types of online gauging available today. So what does this bring to the shop floor that is not available in the existing shop floor gauging?
Well, gauging has its own advantages and it has its own limitations as well. So there are always going to be certain parameters for which you will have to go back to your CMM and say, I'm not able to check this on my gauge. I need to go and do a complete inspection on the CMM. This is going to take you a lot more time to build a program and get set up.
Okay. But normally, I mean, I've heard of some other shop floor CMMs, right? Like Trimos themselves, we make 3D measuring.
Yes.
There are other good competitors also in that segment in the market. But normally, well, they are good in piece of equipment, but normally we've been, for the precision machine sector, we've not really been aware that they are accurate enough.
Yes, and it's because these machines are manual and you are not able to get the repeatability that you would like to achieve on the shop floor. So you have a limitation when it comes to the accuracy you are able
No,
to.
because normally they are like 40, 50 micron. I mean,
Yes.
they're 20 plus micron accuracy, and then as R&D, we say 40 microns or so. But then what is, so how do I see it to a precision machine shop?
What is unique about this machine is, despite doing the measurements on the shop, the repeatability is remarkable. Within few microns, you're able to get repeatable results.
And what about but accuracy still be?
So the accuracy is still rated at 8, but you are able to establish a rate at 8 microns.
8 microns. Okay, is that is what is it? Linear volumetric?
It's volumetric.
Volumetric accuracy. So volumetric accuracy is 8 microns.
Yes.
Okay. And is that across the range of the scale?
It is across the entire volumetric measuring of the scale.
Okay. So, but basically, it seems like a pretty handy portable unit, right? I mean, what is the size range?
So you are able to have a measuring range of 250 mm in height, which is your depth, and you are able to cover an X and Y range of 270 mm. And this goes around radially all the way 360 degrees. So you are covering a cylindrical volume that is effectively 500 mm.
Okay. But if I'm thinking about, so you said it's 8 micron volumetric accuracy. This machine. Okay, and we were talking about the range, the size range of this machine. Okay, you're telling me it's a radial machine, and that is all very good. But what would be the typical largest component that I can measure on this?
Imagine a part that has been put, a level tilted here, and you can try out a part that is 300 by 200 rectangle.
300 by 200. Okay. So it seems like an interesting machine for small components. And of course, I can see it is a fully automated machine, which is pretty interesting. But okay, now coming back. So normally, in plants, when we take components to the standard room, we have a typical challenge of soaking. Basically the parts are at one temperature in the shop floor, and the standard room is at another temperature in the shop floor. So how does that whole equation, the concept of soaking, the concept of temperature, how does that play in for the C4?
Well, there are two aspects to this. One, your machine is already on the shop, so you don't need to soak it and bring it to a standard room condition, unless of course you have an application that demands it. So, but typically this machine is built for the shop floor. The scales are special sandwich material scales from Renishaw that help you adjust the environmental variations and give you good enough measurements within the shop floor.
Okay, but so what you're saying is that because it is measuring at the shop floor temperature, so I don't have to say.
Yes.
Okay. And but then my drawing calls out for standard room temperature. And then, but if my shop floor is at 30 degrees, then how do I adjust? Or do I need to do some sort of a process study, or what do I need to do?
Again, there are two ways about that. You can either go for a temperature compensation, which is an optional within the software of the machine. And of course, you can also establish a correlation study between the variation you are able to achieve within a standard room temperature condition and the result that you are able to achieve on the shop floor.
Okay, so now I get it. I think what the right approach would be that, if I have a bridge type CMM in the standard room, which has already been taking measurements, I can take a series of parts, measure on that. I can measure them in my shop floor ambient, and then prepare a process sheet with specifications.
Exactly.
Okay. Okay, that can work. And now, what about okay, it's portable, it's automatic, it's nice, it's very neat and handy, but what kind of, how can I deploy it on it? What kind of real ROI, what kind of benefits do you see?
Typically, what we've observed on the shop floor is that they, because of the load on the CMMs, they tend to not go for 100% inspection on the parts. They would rather go for sampling and rest of the parts are checked using gauges and relation gauges or other standard typical methods that are used on the shop floor. But this allows you to go for 100% inspection right there on the shop, and you can go for your sampling. You can reduce the frequency of the sampling on the CMM as well. This decreases your load.
Okay, so could you say, for example, that so sampling inspection? I can imagine that probably we could, I have a series of machines, machining centers on my shop floor, and every 4 hours I need to take the components to the standard room for inspection, and of course they have to, take the components. They have to wait in the, they have to wait in queue. They have to soak. Then the CMM would give the report, and then the report has to travel back to the machine. So instead, you're saying that actually, yes, I see, we can take the machine, we can take the C4 to the point, to the near the machining center, but and then we can do the inspection.
Eco, what do you problem with which item?
Eco, right? Is there any other?
I don't think we are logging on.
Mostly room environment के वजह से भी बंद है ना.
Just open that group.
There will be noise something maybe the other.
Open that group. Okay. So we're talking about how we can use it, for example, for routine, in process inspection, sampling inspection. So I can see that we can take the C4 from machining center to center or from cell to cell. We can take it there, and the sample part can be pulled off the machine, and then and there it can be inspected. The critical, we can prepare a program for all those, CTQs or critical parameters that need to be inspected. And we can, then therefore the operator has the report then and there on the spot, rather than waiting for, half an hour, 45 minutes before the part travels, soaks and gets the report back. So that's a definite advantage that I see. But on the shop floor, if I am people, after all, it is a CMM. It's not, it's not like a vernier caliber. It's not a simple instrument, right? What kind of infrastructure do I need to run this on the shop?
It's self-sufficient that way. It doesn't require any, additional infrastructure. It does not require analytics. It's thermal motors based, and the very easy setup for this is you don't even need a granite surface table.
Okay.
You just need a stable surface that does not shake. So you can just set it up using these kind of base plates and fixturing accessories, and you can build programs and run it right there.
Okay, I see. But is the machine to be clamped or anything to the plate? How does it?
It doesn't require any such arrangements. Yeah, there are. You just match it to the holes available on the.
But then I see you have a small blue plate over there. But is this required?
Well, it's not required always. If there is no requirement for clapping the part, it's simple enough to just put the part and go for an inspection. You can do that.
Okay. So, but then what would be the benefit of? If this is not needed, then why use it?
Well, it offers flexibility in terms of fixturing when it comes to components that are more difficult to fixture.
Okay. So, are you saying it is repeatable? You show me on this one.
So right there, this is your own fixturing plate. You can you have your holes. You have a set of fixtures that you can just use to clamp the part, and you can just plug it into this. There are a pair of magnets that allow you to interchangeably remove
and of course, what will take some you need to have set up repeatable fixture units, modular components which are also supplied with the unit. So, okay, that's great. Okay, so incoming inspection is one thing, but you know, I know, I mean, that be the only place that you see any other use cases or any other uh, areas where I can deploy the C4?
Well, in speaking of incoming inspection, then you can also explore the option of taking the C4 all the way to the vendor's end, and you can do the inspection right there at the vendor's end. And you have some kind of a correlation between the measurements done here and there. And secondly,
Okay, Mr. You can come.
yeah, and the other application would of course be, right on the shop floor. You can build it within an automation cell.
Oh, okay, wow. So when it comes to automation, so you are saying that it can talk to my other factory.
It certainly can. There's an additional module available on the Apple software, which which can be set up to give you an input according to the inspection of the part.
Okay.
So you can discard or accept the part and move it ahead.
Okay. So for example, we spoke about incoming inspection, online incoming inspection. We spoke about automation, factory automation in the cell. So it will send the data directly back to the machining center or whatever.
Yes, it does have the option to do so.
Okay. So yes, we can have online error correction. Maybe.
Yes.
Yeah. And but then what about other things? Setup changed.
It's the perfect machine for the first article inspection.
Okay.
Typically, moving your first part after it has been made to go and get it inspected on a CMM is a huge hassle. You often encounter huge queues and you don't want to wait too long. And this machine can do the inspection right there, give you the results. You just enter your whatever values you are able to measure into the machine, and your first article inspection comes in handy for that.
Okay. So in fact, for setup change again, yeah, of course, I can take the machine to the floor and then to the very rather than I mean, how would it save me time as compared to like today, for instance, if I run a plant where there is already a bridge type CMM which I'm using for first article inspection after a setup change. How would this change that process or flow?
Well, first of all, the software is extremely user friendly. You don't need a dedicated CMM operator. So let's say the CNC machine operator himself is trained within this. You can have him do the first article inspection then and there, and input the values and corrections within the machine. And this avoids any kind of lag, and there's no delays within this process, and saves time.
That's true. I mean, because again, it goes back to the same things I think we already spoke about. No need to transport the component to the standard room. No need to soak the component. No need to wait. If there is a queue at the CMM, I guess I could put this on my setup change trolley, bring it near the machining center, set it up right there, take care of my the component inspection, and if at all there is some iteration, again the feedback loop will be extremely fast, right? I mean, whatever I test the first part out, I can immediately measure it then and there and load it back. So yeah, that I can see as a pretty. I mean, definitely could have a good impact on setup change downtime in most plants. But you spoke also about the software. Right? Can you tell us more about?
So the software that we are running is full-fledged CMM software. Aberlink is the UK-based CMM manufacturer, and we have adapted that software to this particular machine. The beauty is that the initial programming is done completely manually. It does not require a joystick, so you just move your slide around using the probe. You hold it here and do the programming.
Right.
And once the program is built, you are good to go and you are able to run it on auto.
But can you show us that?
Certainly.
Earn accelerated rewards on your daily spends with your pre-approved Yes Bank.
So this is where you have your TP20 touched in your head. That you can easily go down and look at the points. The software is built in a very easy manner. You can just select the features and go and go. It works on teach and learn method. I'll start with the play. So I've just taken a couple of features here. The exciting thing about the software is you don't need to rely on the points that you're taking manually. You can just go and automate it so that the points are programmed within the software. I'll just make a uniform penetration. We'll go for the feature array feature. And I have 6 holes that I have just copied here. Plain row circular. And I have a program ready already. Oh.
That is pretty nifty if you ask me. No, so no joystick. Where is speaking of? Is there a joystick to this thing?
There is
No, but then why do you have a need? You can just, it is a manual or to CMM and you're just able to run this, I guess it's like. And that is pretty neat. But is this the only way of programming? I mean, do I have to teach it every time?
Well, this is the easiest way to program. There is also the option of doing building the programs offline. That's an offline tag module.
Correct. So I can use, for example, my 3D CAD format.
Certainly.
Yeah. Which formats can I use?
You can upload IGS and stuff, and you can program based on that.
Okay. That is available also.
Yes.
Okay. Fantastic. And yeah, I mean, I think that any other salient points that you can think of that of this machine? It's pretty interesting.
Well, it's the only machine that brings the beauty of manual programming combined to auto.
That is true. So, to everyone, I think that this is really what I can say. It's one of the most unique machines, instruments that is been brought out to the metrology, world in recent times. I can say, based on everything that Vishesh has just told us, that we've spoken about lean manufacturing for years and years, and lean manufacturing talks about a reduction and elimination of waste, right? But on the shop floor, we look at what steps are value added, what steps are non-value added, and we ruthlessly try to reduce the non-value added, the time, work content, etc. But too often, we feel that the same thought process has not yet permeated to the world of quality and metrology, right? When you can talk about lean manufacturing, why can we not talk about lean inspection? Why do components still have to travel all the way across the shop floor? Why do they have to wait in queue, right? And then why does the report have to travel back? If we take, if we look at a component that is traveling through a standard route for some particular inspection, of course, in many cases, you cannot do it any other way. But if you look at that process, you have maybe the travel time for the component to get to the standard room might be a few minutes, let's say 5 minutes or so. It might wait there another 15 or 20 minutes for A, for soaking, or B, for just because the particular machine, be it a CMM or contracer or whatever, the machine might be busy, so it has to wait in queue, and then it gets loaded. The actual value added time in this case, which is the program running time, maybe only 5-6 minutes. And then the report has to travel back, right? Another maybe 5-6 minutes. So all in all, we very often we talk about waiting for half hour or more for an inspection process that really took only 5 minutes. So again, in classical lean terminology, you have almost 70 or 80%, which is non-value added time, and maybe 20-25%, which is value added time. So the whole thought process is, why can we not bring lean to the flow, to part flow and to the measurement process flow? And that is precisely what this machine is intended to do. As we said earlier in this, in this call, in this webinar, it is not intended to be a replacement for your standard bridge type CMM. Bridge type CMMs are excellent machines. There are certainly, they will always have some capabilities that this is not built for. This is a machine that is built for portability. It is built to be lightweight. Like we said, it's like carrying a 3 or 4-year-old child. And that means there are certain limitations. You cannot, it uses, by the way, Vishesh, can you tell us a little about the probing system?
Yes, certainly. It's the most simplest probing system on the market. It's a TP20. The
CP20 made by
Renisha. This is a touch-trigger-based probing system. It does not offer huge accuracies, but what it does offer is flexibility.
But nevertheless, it is well proven for the less than 5 microns.
Yes, yeah. Against the scanning probe, of course, there is a bit of a compromise here. But what it does offer is it doesn't ensure your probes don't get broken now as frequently as they do. And the machine has its own tail stop. If it encounters a part, it will automatically stop. It won't do no crashes. I don't have to worry about the styli breaking. Okay, great.
So coming back, so yes, it has this machine. It is built to bring lean to the quality flow. I mean, so as it's been designed with the Renisha TP20 module. It cannot, it will not do scanning. The probe cannot rotate, like a motorized indexing head, like for example in Renisha terminology, the PH10. However, the probe does spin around. There is an axis, a fourth axis over here, right? And therefore, this can work very well as a star probe. And so this is something also that is very interesting and makes this machine excellently flexible. Vishesh, you show them the various axes of this.
So here we have the vertical axis. You have 250 mm of region range.
And this axis we call the
Z. Okay. And here we have the X and Y, which is at 270.
But that's the rotary and
that's it's the range that has been covered in X and Y. And then additionally, of course, we have the rotary axis here, which we call the C axis, which is available for full 360-degree rotation. And the unique selling point of this, of course, the probe axis, which is again, it's going to offer you 360-degree rotation for measurement of features that are at 90 degrees.
So essentially, if I had this component mounted in such an orientation, I could approach it like this as well, right? Yeah. So coming back, yes. Therefore, this is a machine that is built for portability, right? It will always it will not do 100% of the things that a bridge type CMM can, but it will do the critical 80% of the tasks that a bridge type CMM can to help you offload that work from the bridge type CMM, which is a primary asset in many manufacturing plants, right? So this is something that you can take to the shop floor. You can offload. You can keep your bridge type CMM focused on the most quality critical tasks There is a difference in accuracy, of course. This measures of 5 to 8 microns volumetric. Bridge type CMMs will give you 2 to 4 microns volumetric accuracy. So, but you can, that still is, more than sufficient for, most of the precision machining applications, except for the tightest tolerances, say below 10 or 15 microns. Right. So you can actually use this to offload 80 to 90% of the dimensions that are to be measured on a typical component. And you can save the most critical inspections on your bridge type CMM. That, that is one way it can be used. It can be used, as Vishesh told us very nicely. It can be used to reduce your setup change downtime. It can be used to do online, at the point, online inspection at the point of manufacturing. And not only, of course, is that a time saver, but it also has a very big impact on quality. Because, for example, if I am running online, and I produce a part and I've sent it, every 2 hours, I must send a component as per my control plan to the standard room for inspection. So I take a part out that's being machined, I send it out to the CMM, and let's say it takes about 35 minutes for the component to come back with its report. And at that point, we know that there is a parameter that is out of spec. Now, the entire 35 minutes worth of parts, right, plus the that entire lot is subject to being quarantined. On the other hand, if I'm able to bring my CMM to the point of manufacturing, and if I'm able to get the report in 7 or 8 minutes, then the only loss I've had is so many parts that were produced in 7 or 8 minutes. And that is another huge, not often recognized benefit in your quality process, right? So this is another significant benefit that this can offer. So overall, this is a machine that is intended, it is a productivity machine in the metrology world, really. It is intended to make your measurement process more efficient. It is intended to make, reduce the overall lead time of getting the measurement reports from the point the component was manufactured. And so those are the salient points of this machine. And with that, you have anything else, or those are the points that we have to add. So we can open it up. This is the Trimos C4. Trimos, most of you may know, but it's a Swiss company. It's one of the foremost of the very, very well-known Swiss companies. You can rotate it a little bit. We have Trimos has always been known for their height gauges. We have a V4, we have a calibration class V9. Trimos has been known for their ULMs. This is a calibration class ULM, a setting class ULM, right? So, but now Trimos has entered the world of 3D, right? Traditionally, Trimos was in one-dimensional height gauge measurements and calibration, but now Trimos has entered the world of 3D inspection. And when they did so, they did it by thinking, what can we do different? We do not want to produce the same kind of bridge type CMM that right? We have the standard bridge type CMMs, but Trimos basically thought, what can we do different? And this is the thought process that has led to bringing to market this fantastic product. The C4 has already been in the market for a little while. There are already several Indian customers where it has been deployed. It's been deployed worldwide in other markets very successfully, in Europe, in the US, in Japan. So yeah, we do look forward to you learning more about this product. We are more than ready and happy to bring it to your shop floor for full-fledged demos. Again, this is not just a metrology product, it is a productivity tool, right? So when we bring it to your shop floor for a demo, we don't just want to bring it for 1 or 2 hours just to show you the metrology capabilities. We want you to deploy it in your floor and think about where you can derive the maximum ROI from this product. So when we come there, we welcome the opportunity to stay there for a full day or even longer if required, to where you truly appreciate what benefits the instrument can bring you, right? So that is the presentation. I should also say a couple of words about our company, Trimaster Metrology. You can see behind me, we are an OEM representative of various companies such as Trimos. We are not just a dealer. Whatever products that we present about, we not only do the sales and marketing, but we are also your one-stop shop for all post-sales support, whether it is application support and training, operation training, warranty goes through us, annual calibration, servicing, breakdown support. We have a team of 40 plus engineers located in 16 cities around India. So we are there, almost we're there in every manufacturing hub. In that sense, we are one of the companies in metrology with probably the largest, on the ground staff strength of service and sales engineers. So that is about Trimos Metrology. With that, thank you very much, and we open it up if any of the customers would like to ask any questions.
Yeah, there is a question here.
Yeah.
Is there a scanning bore phase option? If so, could you please show us?
Sorry, scanning?
Is there a scanning bore or a phase option? Could you please show?
So this cannot do probe scanning in the sense it cannot just touch and drag across, because it is a Renishaw TP20 head. It is a touch trigger probe. As you saw in the program, it can basically touch make touches. So it cannot scan. But I'm not sure the customer who asked this question, could they clarify? Is this what they wanted to know, or was it something else? Would whoever posted that question, would you mind clarifying if we have answered your question? Okay, I hope it was answered. But no, it does not do scan. For scanning, we must rely on the bridge type CMMs. The reason is because also scanning probe head requires a lot of there is a lot of mechanical components which are here on the probe head, which adds a lot to the weight and also to the mechanism that must hold all of that. As this machine is built for portability, it will not handle scanning.
One more question by Murugan.
Yes.
What is this? What is the accuracy and repeatability?
Right.
Yeah. So the volumetric accuracy is microns, and we are able to achieve repeatability well within 1 to 2 microns.
Sorry?
You are welcome
Not
to
you.
speak your questions up also, please. We can have a conversation. Also, I should like to add the room that we just showed you over here, which is
Murugan wants
Yes.
to hear once again
Yes.
because your voice is breaking.
Oh, okay. I will repeat. The repeatability you can get typically around 2 microns. The volumetric accuracy anywhere across the entire range of the CMM is rated, at up to 8 microns. Depending on the size, you can generally say we can achieve between 5 and 8 microns volumetric accuracy. So volumetric accuracy 5 to 8 microns, repeatability to 2 microns thereabouts. Hope that was clear. And as we said, we are happy to bring it to your shop floor for detailed demonstration so that you can see how it works on your own components. I was saying the other thing is that the room that we are presenting this webinar from in Pune, this is our experience center. You could see, of course, that we have a variety of equipment. Just this room is also an NABL accredited laboratory for height gauges and 3D arms, because we calibrate the instruments that we sell. The purpose of this room also is it's not just as a demo center, of course, but any components that you have, you are also welcome to send your components to us. We do develop the programs for them here to show you how they work, to show you the measurement performance. So, and then we can conduct specific to any of you. If you send us your component, we can develop the program here, and we can have a similar video call like this to show you the the program running. We can share with you the measurement reports, so you can conduct your a complete metrology process, evaluation, equipment evaluation. You can conduct it completely remotely, thanks to the infrastructure we have built here. And of course, whichever of this equipment is portable, such as height gauges, the 3D measuring arms, the C4, we have other smaller instruments, variety of them. or whichever are the portable ones, we do have a very routine process of bringing out the equipment to your facility for demonstrations as well.
Murugan has one more
One
question.
more
Yes.
question. Yeah. Calibration
Yeah,
frequency.
he's asking for the calibration frequency.
Calibration frequency, I will address in general. We recommend annual, right? We recommend annual. However, it is always ultimately, even as per NABL or any, advanced quality body guidelines, calibration frequency is ultimately determined by you, the end user, right? So if there is a particular equipment that you are using in very routine fashion, you want to get it inspected once a year. If there is a piece of equipment that is not used so often or not subjected to so much wear and tear, you could define it as once in 2 years. We have also known of customers, for example, who use rings and plug type gauges very, very frequently, which have high wear and tear. We have known of customers who even calibrate those at 3-month and 6-month intervals, right? But for this equipment, in general, our recommendation is 1 year. And and ultimately it's up to the customer.
Hello.
Yes.
I want to know the X and Y travel limits for the CMM, or which size of workpiece can I check on it in the X and Y cross section?
Yeah. So in X and Y, for example, let us say just use this as a sample. If I load this is a notebook, but I just show it here. If I load it like this as a component, the X and Y limitation will be about 300 millimeters by about 200 millimeters will be the largest XY envelope that I can measure on this instrument.
Okay, thanks.
Yes.
Good afternoon, Mr. Venkat. We are from Harsha Engineers Limited.
Yes.
Along with me, my CMM team is also present. And
Yes.
first of all, thank you very much for inviting us.
Thank you,
So
sir,
now
for
we
joining.
have 2-3 points to understand.
Yes.
So first, we are manufacturing the bearing components, bearing cages. Most of our bearing cages in the brass segments are the round diameter.
Round diameter, yes.
Yeah, round. So from 25 mm ID to 1000 mm ID range we have in the different commodity of the cages. Right.
Okay.
So with this application of your machine, we think that we can measure approximately 150 to 200 mm diameter. Am I right? Okay.
That is right. Up to
So
about
now we
200
are
millimeter
using.
diameter, you can.
And we can also put the machine in the center and measure.
Yeah, for the very large rings, right?
Yeah.
You can actually set the machine in the middle. The bearing can come around.
Oh.
Like you can set the machine in the middle of the bearing and have it go all around.
Surrounding the machine, we can put the part. Okay.
Sorry?
So that surrounding the machine, we can put the part. It is okay to measure.
Definitely. Definitely.
Oh, okay. So what we were
That is also possible.
assuming that only outside we can put the part and measure. So that was our doubt. Now you have cleared our doubt that we can put the part surrounding to the machine itself.
Yes, and if
So
you
at least
if
we
you put
can measure more diameter up to 300 or
up to about
350
700 millimeters, you can measure.
Okay. Next
700.
point we have, we are using Calypso PCM program. Customer.
I have one more
Okay.
question. Probe
Yeah, go ahead.
calibration, any master available? Yes or no?
Yes. We supply a standard sphere with the master there. Basically it's a standard sphere that we use for probe calibration.
Hello.
For the calibration of this, it is quite simple because again there is an automated program and you just set the probe here and you select the respective option. Yeah. So we just set the sphere like this and there's an option in the screen. We bring it up above and we say start and it for both vertical as well as horizontal probes, it will run an automatic cycle to run the calibration cycle and calculate the probe constants for each.
Darshan sir, please go ahead. You can ask your query. We were asking earlier.
Mr. Venkat, we were disconnected for some moments, so we could
No
not
problem.
view your voice. So now you clear our one doubt that we can measure up to 300, 400 mm diameter and put the part surrounding to the this Trimos.
No, if you put the part surrounding the C4, you can measure up to 700 millimeters diameter because this
Yeah,
this here is 270
we extended.
and
This will move.
this
Okay.
this diameter is 160. So 270 plus 270 is 540 plus 160.
Okay.
The total reach will be about 700 millimeters. So you can measure, say, about 10 or 15 millimeter under that. So you can say 680 millimeters, you can measure safely.
Okay. So only thing the part we have to move surrounding to this machine, right? Like from top to we have to put like on the surface
Yes.
plane. Like this, absolutely. Perfect.
Actually,
So-
I mean, yeah, you may keep the part first and then keep the CMM out. Yeah.
Yeah. Okay. Second point is that we are having the approximately 300 to 400 part of the same product family. Like, so we have to, how we have to change the program, means PCM program or for say one program for the different part number. So that is possible for the one part for the different program. Only thing we have to change the XY coordinates. Right.
Oh, okay. So what you are saying is you have parametric, you have like parameters.
Yeah.
You just want to
Different
change,
diameters.
is it?
So
Yeah.
the
Yeah.
features to be measured on the parts are they similar?
Sorry, sir.
The features that you would like to measure on all the parts are they similar?
Yes. Different in size.
Different in size.
So, features.
Yeah, that's what I understand.
600
They
to
have
700.
similar parts
Right.
of
Guys.
different sizes, but you just,
Yeah.
so it's parametric programming basically.
We can explore this.
Yeah, it is possible to explore. We will have to just talk to the, see, basically the standard CMM software. Normally, the standard approach is that for every size, you will build a new different program and you will open up the program for that specific part. If you have the same, if you have a many number of similar kind of component, it's something we can ask and find out if it is possible to create some parametric programs.
Perfect. Okay. One more point, there is any facility of the temperature compensation? Temperature compensation?
Yes, in the software, we have software based temperature compensation. So in the software, you can select the material that is being measured and you can enter the ambient temperature and then the reports will be automatically temperature compensated based on that information. Theoretically, of course, yeah.
Okay. Fine. And you have the different variety backside also one calypso means Trimos is there. So different sizes are available for the same machine backside.
We're talking about for the height gauges?
Yeah, this is the bigger one. Okay.
Yes, yes. So this is a
Okay, perfect.
this is a V9, this is a 1100 millimeter height gauge.
Bridges.
Of course,
Yeah.
the tolerance is 1800 millimeters, but that is sold very rarely. Up to 1100 millimeters is pretty frequent, particularly in Gujarat.
Okay. So mainly this your regular instrument we can prefer for the soft floor practicing. At moment we are maintaining the CMM in the CMM room. We have a CMM room and maintaining the 21-degree temperature. So for
Yes.
this particular instrument, what temperature needed? Same 21 degree or yeah.
No, the standard operating range is from 10 to about 45 degrees Celsius.
Okay. So it is not is advisable to put in the soft floor in the normal temperature.
No, it is, as I said, it is 10 to 45 degrees. So you can run it in the regular floor atmosphere. In
Okay.
fact, with Trimos instruments, you can see that there are some instruments which are gray color, like this height gauge, like the C4, then also show the HS3, right? So the Trimos makes some instruments which are gray color, and some instruments that are white in color, right?
Correct.
Like this 83, like V9. So all the white instruments, they are intended to be used in lab. All the gray instruments, they are intended to be used on shop.
Absolutely. So normally we are interested for the shop floor on the Gemba measurement. So at present,
Yes.
what is happening that the particular machine operators is giving the parts to the CMM room, which we are maintaining our centralized CMM room. So that is taking some of the time. And
Yes.
after that CMM measurement, that particular parts operators bring back and do the correction in the machine. So
Yes.
if we keep such type of instrument into the shop floor, operator himself can measure the part and take a call for his machine correction. So that was our idea, what we understood from your presentation.
I didn't hear the last part.
Yeah, what was my point? That if it is feasible to keep in the shop floor in the normal temperature, so
Yes.
our operators, machine operators can do the measurement themselves, and
Yes.
which we can offer like as a operator instrument. Means measure the operators are also, we can measure the operator himself. So that was our point.
Definitely.
Yeah.
That is the point. And in fact, you can see also in the videos, you can see the Aberlin screen. If you look at the screen, or if you focus on that one, you can see that all the icons here are also very, very simple. You know, you don't see any complicated menu structure. You know, there are just 1, 2, 3 menus on the top. You know, and then you see over here, it's very, very simple iconography like circle, line, point, plane. There is no, even for any shop floor operator, if they come, they can instantly correlate what each button is meant to do. So the software also is, it's extremely easy to use. So, yes, and definitely the intent is that with this, at least for simpler programs, you do not need a dedicated experienced CMM programmer. Even experienced shop floor operators can be trained to build simple programs at least on this machine.
Absolutely.
For sure. And we should also like to say that the software here it is using is made by a company named Aberlink. Aberlink is a UK company which is also into CMM machines. So, Gaurav, do you mind showing this? So, this right here is an Aberlink CMM. So the software is standard software built for bridge type CMMs only, right? So every facility that you have in a bridge type CMM, whether it is constructed features, theoretical features, all the reporting facilities that you have for the normal CMM software, everything is available in this. It's basically software-wise it is identical, just that it's a small portable machine instead of a regular. Yes. And the same thing applies also to other shop floor equipment like the Trimos height gauge, etc. Any, the height gauge or the HS3 setting bench, we have at the end the relax scan. All of this equipment can be used quite easily by shop floor operators.
Perfect. Yes, you are right. So last question, that the geometrical parameters like form measurement, linear measurement, and line measurement, straightness, everything is possible on this Trimos. Form measurement and line measurement, straightness.
What measurement did you
Form
say?
measurement. I'm repeating.
Form
Measurement.
So,
Form measurement and the straightness.
I'm not sure if you look at just spotlight the screen alone. If you look at this screen, he already has zoom into one of those and explain it. So here we have circularity, linearity. So on the screen you can see that we have parameters like yeah. So you can see, for instance, that there are for every feature, if it's a circle, it's reporting circularity. For plane, planarity. This is a cone feature here, it's reporting the conicity. So all form measurements are standard like any other CMM. All GD&T parameters, are reported as standard. No problem at all.
You can also select the tolerance. Let's say
you can define multiple datums as per your drawing. You can generate the GD&T dimensions. You can report them with respect to the specific datums. All of that feature is standard available.
Hello, sir. I'm from Anshu Engineers Limited. Myself, Sujit.
Yes.
Yes. I'm having a doubt that the probe head which we are using in the Trimos. So, is it can we rotate it, or can we perform the angular measurements also, or that is fixed?
So the only rotation that is available is this vertical that you can see here, right? You do not
Angular
it cannot
measurement.
rotate it like that. It
Yes,
cannot
like
rotate that
this,
way,
yeah.
but it is possible to hold, like you have fixed angled styli that are available. You can put an angled stylus, but then you have to calibrate it each time and then you have to measure it. So within program, it is not possible to change the vertical angle, but only the, this
Turning up is
horizontal flow of the angle can change. This is available.
Okay, sir. Thank you. And one last question: that can we perform the line of profile measurement, the
Yes.
profile of surface measurement? Is it
Yes,
possible?
we can. You have curves, surfaces, profiles. You can do text scanning. As it's a touch trigger probe, you cannot do full scanning, but you can do text scanning where it just follows a curve and goes, repeatedly through. Want to show?
Also,
he's
can
going to
we
do your scanning.
compare with a CAD model?
With
CAD
both
model
CAD and
comparison.
DXF.
Is it possible?
We can do CAD comparison as well as comparison with DXF for 2D parameters.
Okay, and also you are saying that it is possible to check with the line of profile. Then we prepare the program by using the models. So is that possible to load the CAD models of the IGS files?
Yes, we can do
Offline CAD programming is available. Yes. So basically, on the screen, you load the 3D model and, a simulated probe is shown. You click and drag the probe to, show the feature, develop the feature sequence you want to probe. And at the end, that builds the complete program. And then you can bring the program here and then test it directly. That is also available. You can see here, it is currently doing a text scan of the slot feature on this component.
Thank you, sir.
Okay, thank you.
Thank you.
There is one more question from Mr. Murugan.
Yes.
What are angle or applicable to check in one setting?
Angles.
we can check the features that are well within 90 degrees of each other. Indexing is of course not possible in the same setting. Is that what he's asking?
Is that he can clarify on that part? Read out his
Yeah.
question. Yes, correct.
Yes,
Yes,
correct.
message. Yes.
Any other questions? Okay. If there are no other questions, then we can call this event to a conclusion maybe. Thank you all for coming and spending a valuable time. We will be having more such webinars focused on different equipment, focused on different technical aspects of quality. We welcome even from new customers if there is a specific, not just about an instrument, if there's a specific topic that you would like us to have discussed. We have many experts in this area who are in the area of whether it is statistical process control, whether it is TQM, etc. We can bring in relevant experts and we can and will conduct such webinars in the future as well. So we thank you all for coming, and please keep checking us out, and check out our communications for future such events as well. And if you are interested in this or any of the other products, I think that we have your details, and you can reach out to any of the local salespeople. Alternately, and Uma, I just request you to enter this in the chat box for everyone's convenience. If you have a general inquiry, you are welcome to send it to sales, SALES, sales @trimaster.in. Again, Uma will type this in the chat box. You're welcome to send your inquiry there. If you already know our local engineers in your area, of course, please reach out to them and they will be happy to help you. And with that, I'm very happy. Thank you very much for coming. Yeah, we wish you all a good day. Yeah. Okay. Thank you all.